What would happen if ice were denser than water? Anyone with a highly advanced middle school physics degree probably knows this already. Under normal conditions, ice is less dense than liquid water. That's why ice floats. This isn't exactly a hidden secret of the universe. It's more like a piece of room temperature cheese sitting in plain sight. So at first, if ice suddenly became denser than water, it doesn't sound that dramatic. Ice would stop floating and start sinking. That's it, right? It feels like the water world just got a tiny patch update. Surely that wouldn't break the whole game. Except this tiny patch could send almost every living thing on Earth straight to the end screen. A similar idea appears in the science fiction story Heavy Ice. In that story, there is a planet very similar to Earth, with a civilization pretty similar to ours. A scientist develops a special catalyst that can make ice denser than water. Even worse, it still works no matter how much it gets diluted. Then comes the most classic disaster movie move imaginable. He accidentally pours it into the sewer. The catalyst enters the water cycle, spreads into rivers, lakes, and oceans, and slowly contaminates the entire planet. During the summer, everything looks perfectly normal. People go to work, waste time, complain about the weather, and have no idea that their planet has basically started a countdown timer. Then winter arrives, and everything goes horribly wrong. When the surface of a lake freezes, the ice is heavier than the water, so it sinks to the bottom. Then the slightly warmer water underneath gets pushed up to the surface. It loses heat, freezes, and sinks again. Freeze, sink, freeze, sink. This is not normal freezing anymore. This is nature turning on the washing machine, except the setting is deep freeze. Eventually, the entire body of water freezes from top to bottom. Lakes, rivers, and even oceans could become giant blocks of ice. Most aquatic life would not get a cozy winter break. It would just be game over. And summer would not really fix the problem. Sunlight might melt some of the ice near the surface, but the thick ice underneath would stay frozen. On top of that, more ice means more sunlight gets reflected back into space. The planet absorbs less heat, which makes it even harder to thaw. So, when the second winter arrives, things get worse. Layer after layer of ice keeps building up, until the whole planet could become permanently frozen. A giant cosmic ice cube. Very impressive to look at, but unfortunately not great for the audience inside. This is where Earth's current rules suddenly look very important. On Earth, ice is lighter than water, so when a lake freezes, the ice floats on top. It doesn't ruin everything. In fact, it acts more like a blanket, covering the water and slowing down heat loss from below. That means a lake usually does not freeze solid from top to bottom. The water near the bottom can stay relatively stable, and many aquatic animals survive the winter because of that. So yes, the reason fish can still be alive in winter, and the reason we can enjoy ice drinks in summer, both come back to one tiny fact that sounds boring at first: ice floats. Reverse that rule, and your ice drink may not even get a chance to cool your soda before the entire ecosystem gets frozen like an emergency backup drive. The most ironic part of the story is what happens later. Years after that planet freezes, humans from Earth arrive to study it. And of course, they collect ice samples and bring them back home. Because if there is one thing humans are good at in science fiction disasters, it is finding someone else's apocalypse and packing it into a travel container. So the density of ice may sound like a small, boring detail, but it really is not small at all. The laws of physics are like the source code of the universe. Most of the time, you don't notice them because everything is running normally. But change one parameter casually, and best case, the system throws an error. Worst case, the entire game crashes. It's like a three-leg table. If you saw off one leg, it does not gracefully become a two-leg table. It just falls over. Our universe works the same way. Many physical constants look like random numbers, but together, they support stars, planets, oceans, life, and even you sitting here watching this video instead of being flash frozen by a badly designed water update. So next time you see an ice cube floating in a drink, don't just think about whether it can make your Coke colder. It might also be one of the reasons life on Earth has not collectively logged off yet. That's it for this video. Thanks for watching. If you enjoyed it, give it a like, subscribe, and I'll see you in the next one.